Given a binary tree, return the lowest common ancestor of its deepest leaves. What is the lowest common ancestor of its deepest leaves? For example, we have this tree, 1, 2, 3. The deepest leaves are 2 and 3, right? Because only they are leaves. The lowest common ancestor, well, 1 is their ancestor. It's the only ancestor, so we return the node 1. And given another tree that looks like this, now we have another tree. We have 2 leaves, 3 and 4, but 4 is the deepest. Since we want the lowest common ancestor of the deepest leaves, so we want the lowest common ancestor of 4. In this case, we return 4 because the node itself is allowed to be the lowest common ancestor. So the answer is 4. We have given another binary tree. In this case, the deepest leaves are 4 and 5. The lowest common ancestors are, well, is the node of 2. Although 1 is also an ancestor of 4 and 5, but 1 is not the lowest. 2 is the lowest. So we return the node of 2. If we have another tree that looks like this, the deepest leaves are 4, 5, and 6. Now, the lowest common ancestor will be 1, because only 1 is the ancestor of them all. How shall we approach this question? Since we are dealing with deepest leaves, we are obviously dealing with levels in terms of each node's depth. So if we have information of what is the level of this node, what is the level of this node, the level information of every node is going to make our lives a lot easier. So let's do that. There are many ways to interpret the concept of levels. I find this way to be the most intuitive, where every node's level is the maximum level between the left and right child plus 1. And a null node's level is 0. For example, imagine there's a null node over here, there's a null node over here. They are the children of 4. Now, null node level is level of 0. The maximum level of 4th children is 0. So 0 plus 1 is 1. So 4's level number is 1. Similar for 3. 3's children are both null. So maximum between their children is 0. 0 plus 1 is 1. So 3 is of level 1. Both 3 and 4 are level 1. Now for this node of 2, its left children is 4 with level 1. Right children is in null, so level 0. Maximum between 1 and 0 is 1. So 1 plus 1 is 2, so 2 has a level of 2. For this node of 1, its left child has level of 2, right child has level of 1. The maximum between left and child is 2. So 2 plus 1 is 3, so 1/2 level of 3. There are other ways to interpret levels, but I find this way to be the most intuitive. So let's define level this way and print it out. Since we are doing recursion, we need a helper function. The return type should be integer because we are relying on the return value of our children to know what level we are. If this is a null node, the level is 0. Our left child's level is by a recursive call to the left. Our right child's level is via a recursive function call to the right. My level is the maximum between my left and right child at 1. To print it, let's do Let's do something like this and call it. And see what we got. Four level is 1, correct. 3 level is 1, correct. 2 level is 2, that is correct. 1 level is 3. So now we have a hold of the level information. The level information alone is not enough. We also need to know where the lowest common ancestor comes from. In order to do that, let us just examine 3 nodes only. The node of 1, 2, and 3. Because this taps into the essence of recursion. What recursion really is about local decision making. By local, I'm referring to only 3 nodes, the root, the left, and the right child. And the root needs to make a decision locally. It only cares about the left and right child and itself. So the root needs to make a decision of where the lowest common ancestor comes from. Does it come from the left child, or it comes from the right child, or the lowest common ancestor is myself? That is the local decision making. If our tree looked like this, my left child and right child have both level of 1. So the lowest common ancestor is myself, right? Meaning left and right have the same level number. Lowest common ancestor is myself. If my left child has a greater level number, the lowest common ancestor is comes from the left. In this case, is 4. If my right child has greater level number, then the lowest common ancestor comes from the right. So this is the kind of decision that this node, frankly, every node has to make. So let's make that decision. Just now I said if left and right level are the same, I am lowest common ancestor. If my left level number is greater than my right level number, my left, the lowest common ancestor comes from the left, vice versa. But how do we have access to this lowest common ancestor and return it? As of now, our return type is an int. You can't just change it to a node return type because then we lose access to our level number. So you have to keep int, which is why we can use a pair. So we have both access to the node and the level. If our left is the same as our right, we're going to return myself. And in this case, left and right are the same, so left plus 1. If my left is greater than right, well, let's change this. Since it's a pair, let's do auto. level number will be the second element. So let's do second. Second. What shall we return? The lowest common ancestor comes from the left, meaning it is the first element of the pair. So left out first. And the level number is obviously left out second plus 1. Same for right, so let's copy paste. Let's remove this. Well, you don't need a return statement because now you're automatically the right is greater. And our final return statement will be we can just do dot first. Well, let's try this. This have to be root and 0. Let's also try 1, 2, 3. One, two, three, 4. I hope you understand what this code is doing. At every node, you are doing a local decision making. You are querying the result from your left and the right. Second refers to the level. If my left and right child has the same level, then I myself is the lowest common ancestor. So I have to return myself. Also, you need to return the level number. Else, if my left child has the greater level number, the lowest common ancestor comes from the left, but it is not necessarily the left. And what is this lowest common ancestor? It is the return result, the first element. And now here it means the right has the higher level number. Let's submit. There we go. Let us now do JavaScript. What I'm going to do is to copy paste my solution in C++ and change it a little bit. We're going to write this function call as a constant. Pass in root. If root is null, we're going to use an array. This will be const dot triple an array this should be the second element. Same. First element. Second element. Array. and return see how it goes. Array. There we go.